So basically, everything so far has been a big introduction to design for manufacturing. And here you can see all the details that have to go infused into your design just to get it right, just to have the right thickness. When you have something that will have a rectangle, actually make a curve. And if you have connectors, what do you do around those connectors? So, of course, there's very professional software. This is one of them, PTC, Creo, Pro Engineering. They're really, really sophisticated software. So it kind of like gives you all the stress analysis, and the same as with circuits. That's my specialty. And Altium, it's the thing. What I have to show you is Eagle with Fusion. That is an educational version, but actually you can take it to the industry. So you can see how that design fits the electrical parts to the mechanical and back, and changing, and then doing analysis of whatever, even the render, right? So here you have the links. It's for free for NYU. There's even like a tutorial, like a video of where to click so they validate your account. And Eagle is for free unless you make huge circuit boards. I already shared this link of the Arduino Nano. It's just the Nano with the pins, but I've been modifying it, so you can also use it as a reference. You see I having blue and yellow, something as a case, quite thick, in case that we want to have something maybe sturdy to support somebody shaking it. It has a gyroscope. So here, what I'm doing is thinking a little bit. I work on a grid, and I don't look from everywhere. I look from different views, so either top or front or left. And I'm going to think where to place this board. So I need to put some supports. So this is what I'm doing. I'm creating a little pillar, and instead of like struggling moving things around, you can see that I actually prefer to click and then modify the parameters of the number directly. So the whole thing itself, I am imagining the battery underneath. Maybe I eyeball it with 15 millimeters plus the header's distance. And then when something is like with the Chapu tool, right? Like more or less, I can go and drag, and I can also reposition the different parts just by moving things around. But if I have something more precise to do, I rather use the line tool, because it will allow me to tell it what are the centers, where is exactly where I want to go. And I've been using the 1 millimeter grid, but for something like this, it doesn't really fit. So I need to get out of the grid and be able to put a concentric circle one inside of the other. So once I have that, I can also drag things, pressing Option, and that will duplicate them. Or you can also Control C, Control V. And what I'm going to be starting to think about is, where does this live? I'm talking not only about the plastic shell outside, but also the internal space. And in order to do this, I go back to have a grid. I have a grid of 1 millimeter. I keep like religiously attached to it, so that way it will help me to guide the murky waters of design. So I have the box. I don't like it in particular, but like if you look at it, if I make it too round, it's like a little bit too organic, too weird. I would just make like a radius. So it's what is called chamfer, but also it's a special effect, because also even the corners is affecting the whole thing. And once I have it, I will duplicate it and modify it. And I'm thinking about having a thickness of the walls on like maybe 1 millimeter. So if I have something of 20 millimeters, the inner space is going to be 18. And of course, I'm going to change the texture for having something that is the material to be a whole. And when you combine them together, you have this enclosure that is actually solid outside, uh, empty inside. But that's not all what I need, right? Because I also need a hole for the connector. So I'm thinking a little bit. A cable that comes in is like this USB micro that I have in my hand, and I didn't get a ruler, but it's definitely less than 2 centimeters. And I also wanted to have some shape that is not perfectly rectangular. I always feel that aesthetically is nice when you have a shape that copies the organic shape of the cable. So I have this cable here that is square but with round corners. I'm going to mimic that. Of course, now you look at it and it's red color, but I'm going to change it to become a hole. And once that I have it properly positioned, and I do this not in perspective view, but in a flat view, and I go from the side, from bottom, from the front to see if effectively I'm putting it in the correct position. And and that's the gig of it. Maybe you can say, well, okay, there's such a big hole, dust is going to come in. I don't want it to so big, so you can reduce it a little bit or play with it. But essentially, you want that hole to be centered, and once you get to this stage, it's like, wow, okay, I have a box. What do I do with this box? Because even if you could 3D print it, what do you do with it? You need to open it to be able to put the Arduino inside. So one of the things I've been doing with my designs is like, I have this cube that is whole, and I use it to split the part. So I copy the part into, I have 2 holes, and I just put them in a situation that both of them are going to cut the piece where I want it to be the place to open. So not necessarily a lid, but starting to think, okay, there's this thing I want. How do I deal with this? So I have them there. It's already quite nice, I think. Nevertheless, I will have to glue them, and I don't feel like hand glue, so I felt like it was interesting to go ahead and just rethink one with the other exact size, and then inside a little bit of plastic. But if I put plastic all around, for sure will not enter, because when you have something like 3D printed, the friction is going to be way too much. So maybe to this initial idea that it makes a lot of sense in my head, in order to make it easier to insert, I will have to diminish the area that enters lid with or cover top part with bottom part, right? So this is essentially where I go. Like, okay, there's this thing, but you, as I was saying, you can rework this, right? So I did that and put with a cube that is a whole, thinking, okay, I will cut, and get somehow in a situation that I feel comfortable with the area, and maybe I keep material at the corners that gets inserted into the bottom part, but I leave space for the whole material to expand. So in a nutshell, this is what I've been doing. I'm thinking that this design can serve as a reference. Of course, then you might want to do something totally different. But I combine materials. I use the radius. I copy paste and took what I didn't like, and I think that this could be somehow useful as a reference. Tinkercad is very, very simple. So the thing that I show a minute during the first part of the class, that is a clip for Microbit, was designed by a kid that attended a summer camp, and maybe a little bit the childish interface helps. right? So I actually I like Tinkercad a lot to prototype things for myself. When I have to build something, I don't want to think too much. I go to Tinkercad, click, 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 and I have it in my hands. So I modify a little bit the height, or I could like decide to change the design a little bit. But this is the thing that I was showing, and it's like done by 12 years old. So there's this whole journey, and it's part of what I was thinking, that you can try to think for final. Okay, this is for one of the designs I had. I had a circuit that has like schematic, and this is the PCB, and then the 3D model, and then I think about the enclosure. Of course, the process was not linear, right? But a way of presenting it. And very likely this thing that we went through is like, okay, minimalistic, right? We connected one cable in Arduino. But I think that it's worth showing you a little bit. This is Eagle. It's an educational software, as we were saying, it's free. And you put the things in schematic, they appear in the PCB. And again, you have a grid that you can lock components, and you can move things around and then connect them with traces. Actually, I think that making PCBs is a lot of fun. But essentially, the idea that what you see in red now is going to be copper on the top layer of the circuit board is a way for you to organize the circuit. And then what is blue is going to be on the bottom layer. And then you do the cables around, and whatever you move is going to actually reflect in your design. As I have all these components. I don't know, somebody wanted to make an integration of a mute function that is going to be next to a webcam. So the electronics, that whatever, that's a resistor because I have an LED. We don't care so much about them, but we do want them not to interfere with this main interaction that the user maybe will touch or will like get close to it. And here you have the ability to even line by line draw on it, or you can actually get to zoom in and move things around or connect them however you see fit. So this software, Eagle, excellent for PCB design. It's not as professional as Altium, like that's the truth. When I was in the industry, Altium designer, whoever is in electronics, pro engineer or Creo in industrial design, but or let's say structural design, and Eagle has a little bit of a flavor of being amateur. But you can see I can actually go and see things in different units. I can go and change things, for example, for 2 millimeters, and say, okay, I want to have a grid. I want to move this 1 millimeter, so many. Or I can also, the same as Tinkercad, I click and I modify. So this thing that I had there, I can export the 3D models and catch them from Fusion 360. And Fusion 360, again, it's not what they use in the industry, but it has all the flavor of something that we can start thinking, okay, I can design something really nice. So what you see there actually was done by Andy, one of my colleagues, right? But the circuit inside is one that we were working on, and it also consists on 2 parts, and one of them will fit into the other, so it has to be a little bit smaller, and it has some expansion tabs, and definitely the degree of flexibility that Fusion 360 has is impressive. So in general, you will work with a drawing that is in 2D, and you will extrude features, and then you can even go ahead and render. So I included a couple of slides that he prepared, thinking about this idea, right? Like you have this electronic that you don't know what to do and you want a box. Well, maybe more than that, right? So you can go through a drawing, you can start thinking of a concept sketch. And I included here a link to the mural that we presented for that circuit board that we are making now in collaboration with Microsoft. So it goes through, these are scenarios, this is for people that are visually impaired, this is for people that are hearing impaired. These are the specifications of things they have inside. So not only the circuit, but also all the technical details. And then it might look like a phone case. It might be a wristband. It might be a necklace. I'm thinking of like, okay, a technical drawing like with dimensions. And we went ahead and tested it, right? Like we assemble things. And using inspiration, maybe the order would be more reasonable to have first inspiration and then the cardboard prototype. But that's how we arrived to this little case, and we are making a couple final ones that also will be presented in the whole project, right? Of like teaching others how to make their own assisted technology. So this journey of like, oh, I have an idea, but then actually you do understand what is available, what are the processes, what are the tools. It's super important, and then you will need to communicate the idea. Mural board, great for some hand drawing, whatever thing. But here, for example, with Fusion, you import the design or you design in there, and then you just make a technical drawing. You click and you have a front view, right view, or the home. That actually, that's called the isometric view, when you see something not from here or from here or from here, right? Top side front, but also simulating a 3D space, right? So you also can choose to either represent the object as a realistic object, like putting textures and colors, or with something that the engineers like having when they are going to put dimensions. It's okay, a very continuous line, very thick, indicating the contour, but then dash or very thin lines of what is actually invisible. So with one view, you can actually see through the piece. And that's what you're seeing now, that kind of like I put a dimension there. And the drawing doesn't have to be pretty, but somebody that looks at this with those numbers say, oh, okay, this is up to scale thing. Oh, this is how it looks like. So the things that I was talking about, I really would like to see you being able to 3D print. And there are some design considerations. I think this has too much to just say them out loud, but include two lists of what is called the filament deposit. And this additive manufacturing that will go layer by layer, it's a little bit tricky because everything is like kind of like if you have whipped cream and you're going to put it and try to build with that. So you need to have considerations. What I did in the former example, a pillar of several centimeters tall will probably have problems with that. But I thought it was okay for the sake of having a quick example. And here you even have in this page an in-detail explanation taking you through pay attention. If you're going to print this and it's going to be like this, like a little tree, right? Okay, fine, but the branches cannot be too open, because if you try to do that, like in that arc, right? So if it's like a U shape, it will fall. The branches of a tree will fall. You need to think that the material will be placed on top. So if you want to do that, in that example, we'll say, well, try to print it flat. And when you go printing, there's so many little other details. I think that it would be nice for us to see it with your hands, right? Go ahead and print something. I'm happy to help. And this is the proposal for the final. It's kind of like, okay, let's build one step more, and it's like it's just an expansion of these technical exercises. What I wish is that you take the the effort of going through documentation, both on your user research with the tools you have used, maybe some empathy map, maybe some usability tests. We also talk about the psychoaesthetic map if you want. But how do you arrive here? Did you make concept sketches? What did you consider? Is there a persona you are addressing? And then from these user research insights, go ahead and think about document the technical drawings. I'm not asking you to learn Fusion 360 in whatever, a couple of hours, but I think that it could be that you do something in Tinkercad and you import the design and use Fusion 360 to make the drawing, possible. But it's also okay if you just get like a sheet of paper, a hard copy, and you make the whole technical drawing. So I hope that helps. And see you on Thursday, right?